So hello guys, in today's video we are going to understand arithmetic progression, a very important chapter of algebra, and we will discuss how to add series, how to find a general term of an AP, and what is an AP basically, what is common difference, what is last term, and by all this we will come to some conclusion and we will discuss those conclusion in details. So let us get straight to the point. What is an AP? People ask what is an AP? APs are said to be AP is basically a series, right? When you write 1, 2, 3, 4, 5, it is a series of natural numbers, right? It is an infinite series, so we call it an infinite AP. If you say series of odd numbers, odd natural numbers, so you will find 1, 3, 5, 7, 9, and so on and so forth. And this is also an AP because if you see the common difference, what is an basically in common difference? Common difference is found is is a difference that is found to be common when we subtract any term of a series, any term of a series from. Please note this thing that when we subtract any term of a series, any term of a series from the term which follows it, means there is a term called 3 in the example first, right? You will find a term 3 and there is a other term 7, right? Now if you see, the common difference of this series will be 4. How? Because if you subtract 7 minus 3, it will come out to be 4, and for every other term the common difference will always remain the same. If there is a point I have written here, that common difference never changes. If common difference is changing for every term, it is not an AP, right? So if you think there is a term, there is an example of a series 1, 3, 9, 10, 11, 13, 19, 20, 22. Is this an AP? No, because the common difference is not equal for every term, right? Common difference is common for each and every term in the series, right? Now we will get to another slide and we will see how we will let me just tell you about this example. This is an also an AP because the common difference is D. Whenever common difference for every term, if you say uh, b b plus d, b plus 2d, the common difference is d. If I will say there is a series b, b minus d, b minus 2d, the it is also a series because the common difference is minus d. There is no point on if a common difference is can be negative or not. Common difference needs to be same for every term, just it is the only point. It can be fractional, it can be irrational, it can be anything, right? It can be either be an complex number, but common difference should always be same, right? So this is how uh, things work, and we will go to our next slide. That is, if we examine this series, a plus d, a plus 2d, a plus 3d. So what you see in this, you see the common difference is always less than the number of term. How? If you see the first term is a, right? And the second term is a plus d. Now you notice this is the second term and the coefficient of d is 1, because a plus d can also be written as a plus 1d, right? So the coefficient is 1, right? So this is why we can say that the coefficient of d is always less than 1, the term of the series. So if you say a term 1000, so what can be the general formula of that term? A plus 999d, because the coefficient of d is always less than 1, always less than, always 1 less than the number of the term of the series, right? So we can come to a conclusion. If n is the number of term and l denotes the last or n term, we can write it as l equals to a plus n minus 1d. How? Because l is the last term and n can also be written as l minus 1 is basically the term before it, and the difference, and thus we can came to a point that L, the last term is always a plus n minus 1, the number of terms minus 1 and into difference, common difference, right? Now, what is sum of an arithmetical series? It is very important thing to note what is an sorry, what is the sum of a terms on arithmetical progression. A can be written as first term, D is common difference, N is number of terms, L is last term, S equals to sum required. So we notice that S equals to A plus D, A plus 2D. It can be written as series, and the last term will be L, and the second last will be L minus D, as difference is it is decreasing by D because it is last term definitely, and the third last term will be L minus 2D, and it can also be written as S equals to L plus L minus D, L minus 2D. There is no point. Addition is always commutative and associative, so we can write it as this, like this, right? And now we will add on these series first and second. We will come to a point that 2S equals to A plus L, A plus L, A plus L. All the D's will be subtracted from the series, right? Now, a plus L will be followed by n terms till n terms. So we can write it as n equals to a plus L, and thus a plus L, what we have discussed in previous slide, that L equals to a plus n minus 1 d, right? So L equals to a plus n minus d. We will put this point here. We will we will write this L here. Okay. Now S can be written as n by 2, 2a plus n minus 1d, because a plus a will be added on to 2a, right? So this is about AP, and the further slides will be discussed later on another videos. So please stay with me and subscribe if you like this video.